Fusion Mobile, quality e-learning experience on the go.
Good and welcome to today's class. For our topic today, we'll be discussing the concept of probability. Alright, probability is defined as the technical term of chance. Okay, we can say probability also means chance. Okay, for definition purpose, probability is the likelihood of an event to occur. The likelihood, okay, likelihood that an event occurs. Alright, and so in the course of this study, we'll be defining some terms you encounter in probability. Alright, the first term there is what we call the sample space. Okay, the sample space is a set of all possible outcomes. A sample space is a set of all possible outcomes Okay, for example, we have a sample space of a dice, okay, to be given as 1, 2, 3, 4, 5 and 6. Alright, for those of you who play Ludo, you find out that the cube-shaped object you use in playing your Ludo has points written on top of it. You have point 1, 3 points on some sides, okay, 3 points on some sides, and some having 2 points and 5 and 4 and 6. Okay, so when you roll a dice, 1 point must turn up. Okay, so it's either it's decided with the point 1 or 2 points or 3 points. Okay, so these are the possible outcomes that happens when a Ludo is tossed. Another example is a sample of a coin. Okay, when you toss a coin, it's either the head shows up or the tail shows up. Alright, so with this we'll define an event. We say event is defined as one of the components of a sample space. Okay, of a sample space. Okay, and we already know what a sample space. For example, an event could be head. Okay, hedge in a coin. Okay, alright, so events, all these things inside the sample space are called events. Meanwhile, a combination of all of them are called sample space. Okay, we talk about mutually exclusive events. Okay, we say that two events or an event is said to be mutually exclusive if the occurrence of one excludes the occurrence of the other. The occurrence of one event or excludes the occurrence of the other. Okay, finish up here. Alright, and so we'll take, for example, it is either she's pregnant, it is either she's a virgin, okay, or she is a mother, okay. So if she's not a virgin, she's not a mother. I don't think, maybe this might not really apply to some cases. Alright, but then you can always take some other example. You can always take some. All right, another example is this. We can say there are 10 students in the class. There are 10 students in the class. Okay, suppose we reduce it to there are 2 students in the class. Okay, it is either OB, who is a student, comes out first, or he comes out second, all right. And so you see there wouldn't be a time when OB will come out first and second at the same time. So it is either he comes out first or he comes out second. So if he comes out first, the probability that he will come out second will not be there again. So when one event occurs, it excludes the occurrence of the other event. And so that's what we mean by mutually exclusive events. All right, the next one we'll be considering called independent events. Okay. All right, if the occurrence of one event does not affect the occurrence of the other event, we say that these events are independent. That is, if the occurrence of one event okay does not affect the occurrence of the other events, occurrence of another event, we say that they are independent events. All right, for example, event number 1, tossing of a coin. Okay, tossing of a coin. And event number 2 maybe passing an examination. You find out that these two have nothing to do with each other. Okay, maybe when we define what dependent events are, you will understand better. Dependent events, okay, are the opposite of independent events. Okay, for this we say that the occurrence of one event affects the occurrence, okay, affects the occurrence of another event. Okay, we will take for instance event 1 to be example. Let event 1 be the probability of passing an examination and examination for qualification. Okay, for qualification. All right, and then let event 2 be that an event that states that he can only get a job provided he passes the examination. That means getting a job which requires the qualification. Alright, so we have 2 events and one is dependent on the other, because the probability that he works, okay, he gets a job, depends on his ability to pass his exams of qualification. Alright, and generally we would define probability to be equal to the number of occurrences, okay, number of occurrence of event, or number of occurrences, okay, let me use of events, okay, all over the total number of observation, all over the total number of observation. Alright, so with this we have managed to introduce the terms in probability. Okay, we'll take a simple example, and that's this example 1. Okay, I thought to find the probability of an odd number appearing in the appearing in a single toss of a fair die. Alright, okay, so by solution I would like to state that the possible sample space for these toss are that once the die is tossed, sample space for die is given as once a die is tossed, is either 1 comes up, or 2 comes up, or 3 comes up, or 4 comes up, or 5, or the number 6. Okay, good. Then the possibility that it is an odd number is the fact that it may be 1, it could be 3, it could be 5, because these are all the odd numbers in a dice, in a toss of a dice. Okay, and so the total number of occurrences, the occurrences that are likely to take place are 1, 2, and 3. Okay, the occurrences are equal to 3, therefore probability of odd number in a dice will be equal to 3, and then the total number of observation is 1, 2, 3, 4, 5, 6. Okay, 3 over 6. Alright, so 3 takes care of 6 to give 1 over 2. So therefore you can say that the probability of odd number, okay, in the toss of a die, will be equal to 1 over 2. Alright, so with this we've been able to introduce the basic concepts of probability. Catch you up in the next class.